a modulus equation question, but this one has been, we've added 5 to like a modulus to translate it in the y direction. We're told that the vertex is P, this is where it turns, and we're asked to find the coordinates of P. So this is a little bit like when something's in completed square form. It's going to turn when this bit is 0, because otherwise this bit is always positive. The minimum is going to be at the critical points when basically this goes to 0. So it's going to go to 0 when x is 2, and that's going to leave us 5 is that value there. While I'm at it, I'm also going to work out where the y-axis is. That's going to be when I put in x equals 0. Then I find the modulus of minus 2, which is 2, times by 3 to give 6, add 5, it's going to be at 11. So on to B, we're asked to solve the equation 16 minus 4x equals the function that I just had. Now, I like to do this graphically. They've even given us one of the graphs here, so that's a great start. So I know that this 16 minus 4x is going to cross the axis at 16, that's the y-intercept. Then it's going to have a negative gradient. And in particular, the gradient is going to be more negative than the minus 3x we get on the left part. So it's going to be steeper. But the question still arises, is it going to cut through before that turning point or after? Well, we can actually do a little check here. We could substitute in x equals 2. Then we're going to get 16 minus 4x equal to 8. Okay, so I know that it's going to be here, above the turning point, and that means that it's going to cross after the turning point. You might be somebody who tries to solve both cases and then subs back in and checks. Look, that will work, but ideally you'll draw this sort of graph and realize we only need to look for this solution here. So it will be when 16 minus 4x is equal to the positive part of the modulus, when the modulus is actually not doing anything. So just 3x minus 2 plus 5. Which becomes 3x minus 6 plus 5, so 3x minus 1. And then I get 7x equals 17, so x is 17 over 7. That is our only solution. And you could put that back in and you would see that it worked. So let's just say, for example, you got it wrong or you decided to just do both, then it would become 16 minus 4x equals minus 3 times x minus 2 plus 5, because we're now using the modulus function. We're saying that we're looking now to the left. So you could even say that x is less than 2. This is another way of like checking it, whereas before it was x greater than 2, greater or equal to 2. So yeah, the modulus, if x is less than 2, then this will be negative, and that's when the modulus will do its work. And because we've got a negative, it will then bring another negative in to make it positive. Hopefully you're happy with that. So 16 minus 4x equals minus 3x plus 6 plus 5, that's plus 11. Then we'll get x equal to 5. And we can see by putting it back in, that doesn't work. And secondly, it's not less than 2, so we don't even need to substitute it back in. But anyway, if you draw the sketch carefully, then you'll see that we only need to look at that left-hand part. Finally, this is like the hardest aspect of modulus questions that I see on exams, but it has come up a few times now, so it shouldn't be like an unseen question. It should be something that you've seen before. If not, it's quite tough if you've never seen it. Anyway, let me get on with it. So we're told now a line L has equation y equals kx plus 4. So I know it's going to intercept the axis here. And I'm told that this line intersects the original in 2 places, and we're asked to find the range of values of k. So this is definitely one, though I mean, it's massively advantageous to do it graphically. I'm not sure how I'd do it without using the graph, to be honest. So, okay, I'm looking for there to be 2 distinct points of intersection. So for example, here I would get 2 points of intersection, whereas here I wouldn't get any. And right here I would just get 1. And that's going to give me my first value then. So if I use this gradient, but I went for any value lower, then I wouldn't get any points of intersection until I got to say here, but then I'd still only get one. So if k is lower than this gradient here, I won't get 2 points of intersection. So let's find out where that is. Well, it's going through 0, 4, and that turning point that I found before, 2, 5. So the gradient will be 5 minus 4 over 2 minus 0 is going to be a half. So I need m to be greater than a half. If it's equal to a half, it would still only intersect in one place. Whereas if it goes like to 0.6 even, then it's going to maybe look like that. It is going to intersect in two places. So now I've just got to go the other way and think, well, think about what happens if I keep increasing it. Will I always get 2 points of intersection? And the answer is no, because you can see here, it wouldn't. If I make it really, really steep, it's going to go through that one on the left, but not on the right. So where is the crossover? It's going to be when it becomes parallel to that one on the right. So if it goes any steeper than that, or is parallel, it will only intersect in one place. So we are looking for all values of the gradient that give us lines that are in this region, basically. So we also need m to be less than 3. Because if it's 3, it's parallel. It would only intersect in one place. So it's got to be less than 3. And then we're in this region between a half and 3. So overall, a half less than m less than 3. I personally really like that question, but it's only 2 marks, I guess. But it really tests your understanding of geometry and using the modulus function.